reminds me of one of my famous sneezes. Achor!
Oh, man!
Doesn't sneeze?
It's his comedy routine. This is unreal.
How do you expect us to teach with these supplies? Well, this pointer's so old it's worn down to a nub.
Okay, the mic's meant to be on this time. I admit that I got at the start of the stream. One of the first things I meant to do after going live is turn off the mic. Because otherwise it just projects what's happening in the room. All sorts of incriminating things happening in the tiny 10-minute window that happens before the stream. Okay. Oh, and once again, okay, yeah, that's got to go. That can't be on that screen. That's got to be well away. Got to be well away before I switch over. Anything in here? Anything here? No, we're good. That's literally everything. I think we can. Yeah, we can go. We can go to the desktop now. Hi, hello. How's it going? Yeah. My name is Scott. We are continuing work on the DOS adventure game engine, which I think that, like, I foolishly said would take only one more week. Turns out, real life gets in the way a lot, and also, scope creep gets in the way a little bit. But that's okay. At this point, I'm just enjoying it for the sake of enjoying it, which means I don't necessarily care that much about hard and fast timelines. So let me I'll just quickly kind of like open up to where we were. So there has been actually quite a lot of progress made since last time we were broadcasting, but it's not really visible. It's not really visible from when we look into here. So you may be thinking, hey, this looks like exactly the same as it did before. And to an extent you would be right. But the main difference that we got now is that before we were using like mode 13, which is the cheap, you know, every pixel on the screen is a point in the array type way of drawing to the screen, which is nice and easy from a programming perspective. But the downside is you can only do single buffering, which means you can basically you can't draw to the screen during the retrace. So I don't know, that the screen is set to update at 70 times a second, but you can only ever like draw to the screen memory during what's known as the blanking interval. So like the little period of time when the ray moves from like this corner all the way up to here. But if you set it up so you have double buffering, which basically means you have two copies of the screen in memory, and then while one is being kind of displayed by the cathode ray tube controller or whatever, you draw to the other one, which then means you can just do, you know, nice seamless updates, and you don't have to like worry about timing or anything. The downside though is that the maths for doing that is completely unhinged. So like if we go now to the blit function, or the blit function, you can see here that there is like a hell of a lot more maths than there used to be, and it is mostly about converting planar to, well, it's about dealing with planar. So, yeah, the difference now is that, like, what's it called? There are 4 planes, so pixel 1 is plane 1, pixel 2 is plane 2, pixel 3 is plane 3, pixel 4 is plane 4, pixel 5 is plane 1. So imagine just kind of like jail bar like strips all the way down from the screen, and that's basically how you have to kind of save your image format and write it to the screen, which is why we have like all of this mess here, which is essentially like figure out what source plane, you know, like for every sprite on the screen, you basically have to like figure out, okay, so which plane is the first pixel in, which plane is the destination pixel on the screen in, and yeah, we basically have to do it this way because the way to get things nice and quick in DOS is to copy memory from left to right in, in lines. That makes sense, right? But of course, like, previously that was easy because like left to right in memory was like left to right on the screen. But now it is not that. It is now, I don't know, every fourth pixel is now in the same line, which then means you have to kind of slice it up by that and etc, etc. But yeah, the upshot is we can now do double buffering in VGA, which is quite nice. But yeah, the feature that I was kind of thinking of working on tonight was that, I mean, like, this is all well and good, right? But like VGA came out in 1987. Like, who has, only like the super rich can afford a VGA card. Like, evidently, what we need to do is like what the good people at like Apogee knew from the start, which is that like EGA and CGA, that's where the money is. That's where everyone is going to be. All your DOS users, most likely, they're definitely going to have a CGA card, but they're most likely to have an EGA card as well. So it makes sense that we would want to make a video driver for our engine, which supports these very popular EGA and CGA cards. And I've had like a little bit of a think about how I would like to go about doing it, because obviously, like, let's be honest here. I don't have the attention span to make a completely separate copy of the art for EGA and CGA. I barely have the attention span to like work on the VGA art. But at the same time, like, so what I was basically thinking is like, we could have a system which is maybe like, okay, maybe like we have a fallback system, which is partly automated, which basically, so I don't know, do I have a copy of the, yeah, okay. So like those are the CGA palettes, but this is the EGA base color list. So you can see here you've got these lovely colors and then 4 shades of gray. So it isn't impossible to because all of this is paletted graphics, we could just do like a nearest neighbor kind of fallback approach, which means that like we just map every color in here to its nearest like EGA palette equivalent. But the downside of doing it that way would be that like everything would look very kind of what's the word I'm looking for? Oh, bad. Yeah, it would look bad. It would just look very kind of flat, and you'd lose like a lot of the detail in there. So maybe what we could do is we could have, we have the nearest neighbor, but we could also do like very basic dithering detection as well. So yeah, like, so we could basically like, because I don't know, where's like a good example? Do I have, hang on. So like if we look up a title which has like a ton of dithering, which is like Conquests of Camelot. Like if we look at some of the screenshots for Conquests of Camelot, do we have Moby Games? Yes, we do. Okay. And we open up the screenshots. No, not Amiga. Why would you look at Amiga? Yeah, okay. So we'll look at this nice picture here of Merlin. But you can see here that like they've kind of, like, for instance, the skull cap here has got like this very basic dithering effect. So like this is Sierra's SCI engine, so you basically get dithering, I think, as like a free, you have the ability to just say, oh, I want to fill with this color, but the color is in fact just 2 colors, that are checkerboarded like this. But yeah, and I mean, like, I understand kind of like the argument that, because we're here in 2024 with our fancy LCDs, high definition LCD displays, like on like, on CRTs, for instance, like this would kind of be more blended together, and you'd get more of a, you definitely wouldn't see this kind of checkerboarding. You would just see, the fuzzy amalgamation of these 2 colors. But nevertheless, like, it is, there's nothing stopping us from saying that, as a start, we can do like a nearest neighbor match and say, okay, what is the, mix every combination of these two colors, and out the other end, if it's closer to like a mixture of those two, then bring out a, the dither. Bring out a dither instead of a flat fill. Do I have... Oh, hang on. Did I turn my laptop on before the stream? I did not turn my laptop on before the stream. Excuse me for 1 sec. I'll be right back. Sometimes I just do like experimentally stuff in front of the couch, which means it's on my laptop. Yeah, okay. I do have it here. So if I copy... Because I was messing around with like just this kind of palette dithering stuff. And I think that might, like, this might be what I want to port over to Lua, so we can do it in there. Pal test. Oh, SCP. And we'll copy PNGs. So like here's like an example of like a very basic kind of yeah, I got myself, didn't I, son of a... Yeah, it's all over for me now. Please don't win nuke the stream. I'm begging you. I know you've got skills, so what are we doing? Yeah, okay, so like here's like the basic color chart from Wikipedia. And here's what happens if we kind of put it through the very basic EGA dithering algorithm. Okay, no, this is like... Oh, that's right. This is the naive conversion, which I think... Actually, I can't remember. I can't remember which one is the newer one. Like, there is some... Oh, is this some... Oh, okay, no, this is before I put in a correction. I think this is the latest one. Yeah. Like, this looks about right. Like, if we go to 500... So you can see here, like, one of the... It's not kind of, like, quite a perfect match, especially because, like, some of the shades don't quite line up when you look at it non-blurrily, if that makes sense. Like, the previous one looked a lot weirder because it was mixing in, like, black with light colors, which just looks... Which, in the vast majority of cases, looks off, so... This one I'd kind of like edited it out, but you can see you can get kind of some interestingly close approximations to like quite a lot of color shades just by doing this. And I believe if I look at the... Yeah, so the way that I was doing it in this script was that I was using, and this may be overkill, but like I was using this color transformation called OKLab, which, because like there's quite a lot of, okay, what do we do? I think it's this one. Yeah, so traditionally if you use like a boring paint program, it'll just try and blend like the linear colors together. Whereas it's possible to kind of use a color space which is more consistently, I don't know, consistent across like chroma. So like, I believe, is that a good example? Yeah, okay. So like this is, so for instance, like this is the, you know, if you change the hue of like an OKLab color space, it looks like this, which is more a consistent, you know, brightness or chroma or what have you. Whereas if you do it in like just a normal paint program, which, you know, does it by a very not scientific adjusting of just RGB, you get this where you can see like these thick bands and such. So I thought I was trying to be clever and use OKLab to try and figure out what the closest color is in terms of lightness and darkness and that. And then eventually I think what I did was I added in... Oh, that's right. Yeah, I added in... yeah, okay. I added in this hack, which basically disabled the use of the use of black with lighter colors, which looked weird, and the use of white with really dark colors, which looked weird. So yeah, basically you can't use white with any of these, and you can't use black with any of these. And then that kind of, yeah, that mostly works, I think, for kind of like merging in, you know, having like two colors of like specific or similar-ish chroma, or sorry, not chroma, what's the other one? Brightness, yeah, that thing. So yeah, we've got this kind of, we've got this algorithm here. Let me just write down. Okay, and let me just quickly write down. Oh no, we'll do that in a little bit. Oh yeah, so the other thing that so yeah, going back to where we were with this. So VGA is really nice now. It's nice and snappy. We're no longer dropping frames, which we were doing before, but we don't quite have. We have like one problem, which is that the audio rapidly goes out of sync. So I don't think that I have. I don't know. I've either muted DOSBox or I don't have the audio track enabled here. But essentially, what was going on, right, is that we've put together our music in Reality AdLib Tracker, and that needs to be updated, or that needs to be updated to the Yamaha card 50 times a second, exactly 50 times a second. The screen refresh rate is 70 frames a second. So even like doing our best efforts to kind of, you know, check to see if that we're within 50 frames a second and do the update, it doesn't line up. And it like, you know, it sounds a bit weird. Like bits of the music don't play at the right time, or they sound kind of like weirdly mistimed. Yeah, it's not great. So yeah, this past week I've just kind of been looking into how other DOS programs deal with sound, especially. Like, would you believe, yeah, this is actually like quite a common problem, and in fact, there are there are several third-party sound engines for exactly this reason. Like, I don't know, like what's a good example? Do I have I don't have terminal velocity. Did I delete it? Oh, jeez. Wacky Wheels. Pretty sure Wacky Wheels is a custom sound driver. Yeah, there we go. So like DOSBox. Yeah, okay. Oh, it doesn't. Okay, it doesn't have a name, but essentially, you know, quite a lot of DOS programs would have their you know, like an individual setup tool like this, and you'll have like your choice of sound effects device. Usually, it'll be like a bunch of cards which can produce samples and the PC speaker, and then music device would be like a bunch of cards which can do some kind of MIDI based playback. Or like FM, which would have, you know, a driver which translates MIDI music into like AdLib calls or what have you. And usually, and yeah, so, and like the architecture for how this works is that the sound drive would basically be its own program. It would be what's known as a TSR, which is like a terminate and stay resident, or an ISR, an interrupt service request. But essentially you would start the sound driver up, and the sound driver would just be basically doing its own thing. And usually like yeah, like I was looking into, what was I looking into? Oh, that's right. Rise of the Triad. Rise of the Triad is like completely open source, and that includes the source code for like Apogee. The Apogee sound system, or AS for short, is included with Rise of the Triad, which is what I was looking at. Hey, funky Mr. Chicken. We're just talking about kind of sound issues at the moment. No, I don't want Icarus Rot. I want the original one. So from looking at the sound driver in like Rise of the Triad, like the way that they the thing that was kind of like getting me was like, okay, you can have like an interrupt, like your separate program which deals with the sound card, but like, how do you deal with the timing? And the answer is the sound driver just becomes responsible for the clock, and then the game just asks the sound driver for absolutely anything to do with time. And that's pretty much how like Rise of the Triad does it. It sets up like its own little kind of service to deal with timing requests, and then basically, yeah, when it's playing back MIDI music, it'll go, okay, I know that the next note happens in like this many milliseconds time, and I'll set up the sound driver to... I'll set up the timer so that every time we update the number of ticks, then we'll call, the play note function, assuming that we match the time interval or something. So, I don't know. This code was actually quite informative, so I have like a pretty good idea now of how... Yeah, it's all here in AudioLib. Because it's actually like quite like nicely documented as well, which is very good. So like if we go into public and notes.txt, you can see the actual notes that Jim, the guy who put together the Apogee sound system, gives to... Because like this is like the package which would be given to basically like every game dev who was submitting games to Apogee, the publisher. Like, part of what they would do as a publisher would be that they would like take their, they would sign up developers and then go, okay, we can provide you like our sound driver and our testing and such like that. So yeah, it's actually like quite nicely documented how like they've got it set up. And in fact, because this is a snapshot from like 1996, it's quite advanced, and you can do things like stereo mixing and like 3D audio placement and stuff like that. We're not going to do any of that in our game engine because it's an adventure game engine, and also I don't really feel like we need to do like digital sound. Like all we need to do is like FM synthesis and PC speaker audio, and like those two should be plenty. But from an architecture perspective, no, it was fascinating kind of like reading through this and getting an idea of how to do it. I'm not gonna do the audio stuff on the stream because it doesn't strike me as very exciting, and also, like I've got a pretty good idea in my head of how I'm gonna do it, and it just basically involves like hitting the sound code that I've got with a hammer until it works, and there's not much enjoyment to be taken from that. Better to do like the stuff which is going to require peer pressure to do, like editing the graphics or like fixing that. So yeah, getting back to this, hang on, I wrote some notes down on my phone which I should probably transfer to the screen. Yeah, so yeah, EGA support, like what I'm thinking, right, is that not only would it be nice to have like EGA support, but it would be nice to have a way from VGA support to check that everything is good. Because like ideally what I want to do, we want to have some kind of like automated fallback for a color, but we'd also want the ability to like manually override colors. Like for instance, Dither looks pretty good on backgrounds, but it looks awful for like foreground sprites like the character here. So like the character is like an example of something where I'd want to be able to manually override and say, these color ranges here are used by this sprite, so do not use dithering under any circumstances and such like that. And then like another thing we kind of need to keep in mind is CGA. So when we add CGA support, like here's your choices for CGA. You get like there are 6 choices for colors. You can either have like, I don't know, grass green, blood red, poop brown, acid green, groupie lipstick red, jaundice yellow, and then like varying combinations of like dark cyan, eye piercing blue, magenta, and white, etc. But you basically you can pick like one of these 6, and then like the hidden superpower is you can change this color here to any of the CGA colors. Because this is technically not part of the palette. This is what's known as like the overscan color. Because like back in the day when you had like an old-timey VGA monitor, right? The image wouldn't go all the way to the edge of the screen. There'd be like a square in the middle which had the image on it, and then like the rest of the screen would just be another color. And then that's what the overscan color is. So yeah, in terms of like how we would do kind of like best matching for CGA, not entirely sure, but it doesn't matter because I think like first stage first, we need to get EGA working. And EGA is much easier because you can just say, you know, as long as it's like one of these 15 colors, one of these 16 colors, you're good. And we already have these 16 colors hard-coded as the first 16 of our VGA palette. So what I was thinking is like, it would be nice if we had like a way of prototyping within VGA mode, like what EGA would look like, so we can maybe like adjust the color scheme. And then like, you know, so basically, yeah, we want to have like the dithering and hinting for EGA colors working like fully within the engine here. And then once that's done, like all we need to do, like adding the EGA driver, that's just math. That's just boring math. Because we already have the colors. It's just a question of like, how do we draw it to the screen then? So the API that I want to add for the EGA stuff, I want to add, so we're going to like EGA dithering. So we're going to need an API called PT set overscan color. Hey Mad Moose, Hercules when? So, I mean, again, like, the work that we're kind of doing here is just going to be general purpose dithering code. Like, there is nothing stopping us from adding in... Because, like, initially, right, I think the plan would just be to add the ability to add hints for, like, what kind of dither that we want. And then with Hercules, it's essentially a monochrome card. Like, you know, Hercules is basically monochrome graphics. And the way that you kind of indicate different colors is with different kind of dithering patterns. So there's nothing stopping us from like extending this to say, okay, there are multiple dithering patterns on the table, and we do it that way. So not immediately, but you know, we're leaving it on the table. We're opening the door to doing like certain other kind of remappers. So we're going to have like, yeah, one API for like setting the overscan color. We're going to have one for setting what's the palette remapper. So like essentially like the way that I think this will work is like when we turn this particular setting on, it will then go through the VGA colors and try and do like a best match with the EGA equivalent. The other thing would be we need an API like set dither hint. So then we could go for like, I don't know. So like for a color, we could, you know, ideally one that isn't like black and white because those are kind of important. We could say, all right, for this color, we want to apply this dithering algorithm, which then takes these parameters. And those parameters could be like 2 colors, which are then kind of multiplexed together using the dithering algorithm. Oh, Mamu says, June is a grayscale mode, weirdly. Not black and white, just VGA with a grayscale palette. Interesting. Yeah, I know that, I think EGA has, like, the ability to do grayscale. I mean, I know CGA is kind of weird in that, like, they have, like, the whole point of, like, this special palette here is that it's apparently for, like, if you have a monochrome monitor. So it's still kind of displaying colors, but these are supposedly, like, better balanced for whatever brightness algorithm that the output has. Hang on, there's some... Let me open up the EGA Wikipedia article. Because I know that... like, what's the... Yeah, because there's like the fancy 640 by 350 mode, which has like any 16 colors you want, and then there is the more common EGA. Hang on, this thing here, like this mode here is more common, where you basically just have your stock 16 EGA colors, and that was popular because it worked with the IBM monitors that they were giving out for CGA. I can't remember if there's specifically... I can't remember if there's specifically a graphics mode just for EGA monochrome. But, yeah. I mean, I do know that also there are other games which do palette tricks where they'll have like, you know, they'll have like semi-transparent overlays, but really they're just kind of like getting the grayscale equivalent of a color. Like I think Blackthorn does that for like its UE and like Heroes of Might and Magic and a bunch of other games. But essentially, like, you can pretend that you've got like semi-transparent glass when in fact you're just kind of colorizing everything to a grayscale palette, which is also something that'd be kind of nice to have in the API for different reasons. But I think that, yeah, we'll do that. So we've got the set to the hint, and then we want PT clear palette hints and PT flush images. And yeah, we're going to need this. We're definitely going to need this one here, I think, even if it's just kind of, you know, attached to all of these other ones by default, because the trick, right, is that we have, I don't know, like for every image that we've got in here, there's like a PNG file which contains like the source data for the image. So like I can open up our project. And we can see here there are just, you know, it's just a PNG with index graphics that we get loaded in. But I was gonna say, yeah, so this here is kind of, yeah, like, so the copy of the image is always kept in chunky format, but we also make a copy of it that's formatted for the display driver. So like if we go VGA convert, yeah, so like I've got this command here which converts this chunky pixel representation here into planes, which is what we need for like accelerated VGA mode and stuff like that. So essentially when we and that also does things like convert the image palette to whatever palette that we currently have set up in the engine. So I think that what, like, basically every time that we change a palette hint, we're gonna have to update or like force an update of all of these kind of hardware or, you know, hardware specific copies of the images. And yeah, we basically need to do that so that, like, say that we add a palette hint saying, okay, this color is now dithered. That would mean that, like, we would need to redraw every image which uses that color to have a dither in it now, instead of just having a fixed color. So I think that this would definitely be the place to do that. We just need to add some smarts about cleaning. I don't know. Yeah, the plan would be that we would have this function here, which would, I think, maybe set a one-time flag so that for the next redraw of the screen, we would just erase all the images that are involved, or erase all the hardware images and then recreate them again. I don't know. This is kind of like another weird garbage collection type issue, because right now there isn't really anything that's keeping track per se of all the images that we have flying around. They just exist in Lua, and whenever they disappear from Lua, then Lua deletes them. And so by extension, we don't really have a good way of just saying, okay, for every single image in the game, go through and wipe out the other one. But maybe we do need that. Maybe we should just add it to some kind of list. I haven't decided yet. But we can do a nasty hack in the interim. Okay, so I think this lays out basically what we need. Hey Arvenla, how's it going? We're just kind of talking about we're talking about how best to downgrade this to EGA. And I think we've got a strategy. So maybe the first thing I should do is convert over this dithering code. Actually, no. First thing I should do is I should just add in all these empty API, all these API calls, and then figure out how we're going to introduce the dithering code. So I think the dithering code is going to have to be written in C, because it's kind of it's going to be one of those bits. It's one of those bits that I don't think we can do in Lua. Oh, Arvenla says, it's going alright. I was hunting down memory buns in Scum VM. Now it's time for some fun. I mean, I don't know. Part of me cringes when someone calls this kind of thing fun. Like, I mean, I find it intriguing, but I can understand that being a very different thing from fun. Like, it's more just kind of like captivating in a puzzle crack sort of way. But hey, you do you. You do you. Okay, so where did I put this code here? Okay, so this is the code which I may have just borrowed from a website which converts to OKLab. I tried doing it myself and it was a miserable failure, so I just borrowed these conversion algorithms from a website. I'm sure the website has the right idea. Okay, and where would we need to put this? We would need to put this... Like, part of me thinks that we would need to... Yeah, alright. So the part of the issue, right, is that we have the stock VGA palette. But I think that we kind of need to have another... Yeah, like we have... So, like, here is kind of our very... like, basically... As far as I recall, you can't just put... I mean, you can... Sorry. I think you can pull a palette from VGA memory, but we don't want to do that. We just want to keep track of it here, and then we have the source of truth. So the tricky part, though, is that in order to do what we want to do, which is to add in dithering and hints and like all this other stuff, we're going to need like an actual source of truth. Now, I think for now, like the way that we've kind of been doing it for now is that we have color, load palette color. No, that loads it into the register. Yeah, okay. So until now, like this has been how we've kind of been doing this weird color thing, which is essentially when we load in an image, like at some point it'll just ask us, okay, like what is this particular color here? Like these combination of R, G, and B. And the answer will be, and so it'll basically try and, oh yeah, firstly it'll try and, because this is the VGA specific one, firstly it'll downgrade it to 6-bit color, because VGA you only get 6 bits per channel, not 8, like you do in normal, like, I don't know, most paint programs. So it does that first. It then checks to see if there's any entry that's in the VGA palette that matches that. And if there isn't, it'll try and add that if there's space. Otherwise, it'll try and do this kind of distance squared calculation between whatever color that we came up with and whatever colors are in the VGA palette. Now, I think, yeah, this has been good enough so far, but for what we need to do, I think we're going to need to have like an actual source of truth palette, which is done in 8-bit color, and then we'd have a device specific palette on top of that, which you know, we use this process to convert between, essentially. Hey, Kinnikos Dragon, how's it going? Oh, Kinnikos Dragon says, so out of the blue, I tried to run Redline in Wine again, and I can actually run it without a critical section declog during low textures. How much do you want to bet later on the how much do you want to bet later on down line? I update Wine and it regresses. Well, I don't know. It's always like kind of a bit of a minefield, especially with something like Wine, where like everything seems to be updating all the time. You know what? You may actually get lucky, because if I recall correctly, you're like this thing that you're testing is from like the 90s, like early DirectX. Is it early DirectX? If I recall correctly, like that code is reasonably. Oh, okay. DirectX 6.1. That code hasn't really been changed too much. Like sometimes, yeah. I mean, obviously, like, you know, compatibility in general is a bit of a crapshoot. Like sometimes there's regressions at like, you know, the kernel level and things like that. But from what I can tell, like the old DirectX drivers, that's not real. I mean, like the bulk of the changes now are happening, I'm guessing, like around like the newer variants of DirectX, which are all like tied in with that new Vulkan based driver that they've got. But at the same time, yeah, it's it can be very frustrating when you know, you update to a new point release and it's like, oh great, the thing that I was, you know, really looking forward to playing no longer works unless I install this really old version of Wine. Oh, you threw in some like, oh, DRIRC. What's DRIRC? Is that like, that doesn't sound like a Wine setting. Is that some other kind of like, oh, it's Mesa. Oh, like Mesa GL. Damn, all right. I've never heard of DRIRC for some reason. Is that because like it uses software accelerated OpenGL, or because I know that like there are some graphics cards which use Mesa as the actual graphics driver using Gallium. I don't know, maybe a few tech revisions out of date. Okay, no. Oh, okay, it is using like the Gallium accelerated Mesa. Yeah, okay. Okay, I do not know about that. I have, like a chump, I have an NVIDIA card, and so I am basically, yeah, everything is kind of a crapshoot as to whether or not the NVIDIA drivers work. It's a great system. Do recommend getting an NVIDIA card. Which, I mean, I don't know. I give them a lot of stick, but at the same time, I'm sure that getting an AMD card would have its own equally frustrating set of drawbacks and annoyances. Oh yeah, okay, so it's the Intel, the Intel graphics sandwich accelerator uses Mesa. That's right. I remember now. Oh, but it like freaks out when says there's too much video memory. Yeah. Games sometimes do that. They don't like the idea that there's too much memory. It's charming yet very frustrating when that happens. But usually it's not too hard to hack around if required. Okay. So the cut point. Where do we need to? I think that where we would need to cut things out, right, is we've got this VGA map color. Where is this currently being called? As far as I'm aware, it's only called here in the VGA image conversion routine. But essentially what we would need to do is we would need to keep a static, like, system level copy of the palette, and then also a special VGA copy. Kineko says, I'm pretty sure that back in 1999, the usual case of video cards was 12 meg of VRAM. Sounds about right. I remember having like a card with like 8-ish megs of RAM, like a TNT2 or something around that era. Yeah, it was special. It was, I can completely understand though, like old programs just losing their mind at like, or worse, like just using like the wrong type of, like using an int to describe like how, I don't know, wouldn't be using an int to describe how many kilograms, but it'd be, like using like a uint16 or something, which is just like not enough to represent the number of kilobytes or something like that. Like that strikes me as something which could happen. Oh, Kinikos, what's changed in the engine so far? There has actually been like, it looks basically the same. On the back end though, it is quite different because what I did was I moved it from mode 13 to mode Y. So if we look now at the that's conversion code. Where did the... Oh, it's here. Okay, so this is now the code this is all the maths that's required now for like splitting an image because everything is split into 4 planes. So like every vertical row of pixels is now plane 1 through 4. And yeah, eventually I basically had to go through like all of this process to readjust everything to run in planes. Like initially I thought I could get away with like, oh, it's fine. I'll just like pretend like it's, a normal left to right chunky image and then at the last second convert it to planes. Turns out that's really slow. The CPU, what it likes to do, it likes to copy things in nice straight lines with very little maths. So that's kind of the purpose of all this. It's basically to like split up every single image into long continuous lines, which I can then just copy into the right planes of video memory. But yeah, the upshot is that now that we've moved to mode Y and it's unchained, it means that we can do double buffering in memory. We've got 2 copies of the screen that are being updated like, when one is being drawn to the screen, one is being kind of displayed, then the other is being drawn in the background, and it just kind of flips the pages between the two. So we're getting like full 70 frames a second with no slowdown or drops. Oh, Avenla says you mean video memory? So yeah, VGA. This is just VGA, but VGA cards have usually 256 kilobytes of video memory. You need 6, and typically that's like enough for 4 copies of like, there's a 320 by 200 chunky image that takes up 64K of memory. But yeah, in order to do double buffering, you need to basically have like 2 times 64, so 128. But to get at that, you need to run everything in planar mode. I don't know, like just IBM, when they're designing their graphics cards, they did not give a toss about how hard it was to program. They just thought, oh well, we've got all these chips, we're going to put them on a board, and we're just going to make the driver interface like a very thin wrapper over those chips. So, not surprisingly, because they had 4 banks of memory, they thought, okay, we'll just have 4 planes and we'll just make the developer like write to... Yeah, so basically like the nice and easy left to right mode, that kind of gets away with it because it's just using every 4th pixel, so technically everything is in one plane. But in order to kind of do double buffering, you need to use multiple planes. And yeah, essentially the math is a hell of a lot more complicated. But yeah, so that's kind of like the main thing which has changed since last time. And yeah, also was going in before that what I think that we need to do for the music driver, like we can play music in the background, but because we don't have a separate interrupt system that's like managing the music and the timer. Like we do have an interrupt for the timer, but we don't have one for the music. And that basically means that like the music plays back at like a wonky speed, or for lack of a better term, because like the screen is updating at 70 frames per second, and the music needs to update at like 50 hertz. So you know the two don't exactly line up. And yeah, I've looked at the Rise of the Triad source code, and I've seen how they do it, and I think I know how to do it, but I'm not going to be working that on stream tonight because that's just like a little bit, I don't know, it's a little bit too kind of spacey to work out on stream. Hey, Mzizzy, how's it going? We're just marveling at some terrible VGA graphics here. Oh, and yeah, that's right. Yeah, Kinnikos, the Apogee Sound System, or ASS for short. Oh, the other thing I probably should be doing on stream, because I've not, again, like peer pressure is really good. I love peer pressure. It's a great tool to actually get work done. Is I should actually continue doing work on the art assets for the game. Do I have art? I don't have it open. Let me just open this up. So we do have... So here's like the first room of the game as it kind of stands now. We're getting there. I'm slowly... we're slowly kind of getting there. I'm getting the hang now of like picking good blending colors. Laying out the room, I'm also kind of getting the hang of now. Like I've figured out how to do... like perspective lines to make everything sort of look better in proportion now. It is still kind of like a little bit of a... It is a bit of a slow process because I'm a perfectionist and I'm also, you know, learning a little bit as I go along. But, yeah, it would be good. Yeah, it would... Honestly, it would be good to have at least one room going, because then we can like fix the final missing pieces of the engine, which would basically be the ability to switch between rooms and having an inventory bar down the bottom. But yeah, for this stream, yeah, I was thinking like a nice kind of little ancillary task would be to add in an auto dithering modes, which would give us EGA and CGA support, or you know, give us the basis that we can use for EGA and CGA support. So I've written. And yeah, essentially, like I've written in Python, like the algorithm that we need to use to convert, like nearest neighbor RGB into dithered EGA palette. The question is like, when we do surgery on the engine, like where do we make the cuts? Where do we make the incisions to make this thing possible? So I think that like the way that we're gonna have to do it is we're gonna have to like be kind of tricky. Yeah, we're going to have to be tricky with how we deal with the palette. And I think that means we're going to have another copy of the palette and then have the ability to do kind of like mods live. So yeah, that's why, because ideally I want to have like an API like this where I can, you know, in the game basically say, I want to override this color here with like these two colors dithered 50-50. And then when we're doing prototypey type stuff, we'd be able to, I don't know, like go through and like make sure that it looks okay. It doesn't look kind of dodgy. Like for instance, do I have no, I don't think I've got one over here. But yeah, that is probably what we're going to look into tonight. So where's the palette? Palette's here. Okay, let's make another copy of the palette. And we'll say that one is kind of the real palette, and another is just going to be the device specific one. Now, where would I put it? I think I'll just put it in system, because that's where I've also kind of like redone like a lot of the engines so that to make it easier to hot plug stuff, because eventually like, I mean, I'm developing this for DOS, but at the same time, it would be nice if we could have an SDL version, which would then mean we could do things like embed it in a web page on itch.io, because then we can build it in JavaScript and stuff like that. And like part of the mechanism for doing that is to create a nice bunch of like flat, boring, easy to do like driver layer things, and then just like, you know, we'll have like the DOS one. You know, I'm basically developing the DOS one first, but then eventually I'll be able to go back and then just kind of like fill in the blanks for like JavaScript, which then means we can have it like on a web page too, or something like that. Okay, but for now, I think that we're gonna just have this as the store for like all of the system specific stuff. Now, yeah, okay, I think we'll just whack it in here. We'll whack it in here. So we'll take in... oh, that's right, I moved all the graphics driver stuff here. So we'll just go... byte palette 256 times 3. That's going to be our RGB palette. We now just need to mod everything to use that instead of VGA palette. That should be fine because we don't have any drawing code there. I mean, we'll have a copy of this, but I think... Okay, okay, so here's like one thing that... So part of what we would need to do here is we would need to go back, like as part of the init procedure for this. Actually no, could we define it in here? Are we allowed to do that? I can never remember in C like what you are and aren't allowed to do. Like in terms of like defining things ahead of time. But essentially like, yeah, so like one of the things that we need to do, like the old design had a bunch of EGA colors hard-coded at the beginning. We don't want to do that anymore. We would want to store them as like 8-bit RGB in here and then have whatever auto conversion system pick up on that. Yeah, I think that's what we want to do. But for, yeah, I don't know. For now, we'll leave it there until we figure out how we're going to do that. But I think that yeah. Okay. And we've got this code here. We've got this some dithering code that we need to convert over. Some of this is just nonsense. Like this. Oh, that's right. This is before I kind of. It says sRGB for all of these. I didn't actually know what sRGB. Like I didn't. For some reason, I just thought sRGB was like from 0 to 0 to 1, like floating point. It is not. It is its own thing, which is very different. But it's like floating point RGB is what I meant. And here we go. Here's like the list of EGA colors which I was looking for before. So we'll go into here. Let's see if we can. I don't think we can do this in C. Yeah, C just like whinges that it's not a valid type. So we might have to do that like in we might have to do that in main, for lack of a better place. Yeah, so like here's our like it's like here is where I kind of set up like very basic, like check if it's DOS. If it's DOS, load in all the DOS drivers into all the slots. Otherwise, crash, because we don't support anything else yet. But we may as well add into this pt sys palette. Actually, we could. No, I think we're going to need to declare it in here. Things, yeah. I get used to things in Python especially, like how nice and easy it is too often, and then I come to C and I remember, oh, that's right, can't do any of that. You gotta, gotta have a salad. Can't just eat ice cream all day. Gotta have a salad. So we'll go byte EGA palette static. Okay, so we'll define that there. We will put in extern byte EGA palette 16 times 3. I think that's right. And then we basically go for I0, I all the way to size of EGA palette, which is something you're allowed to do because we declared it statically. It's like dynamic things you can't use size of. It just won't work, but because it's static, it's fine. We can then pre-fill the palette with this, and then I think like as part of the video init procedure, we would then go through and because yeah, like the init code for the video driver, like basically it'll just call a bunch of DOS things, like do things like, okay, check to see if you've got a VGA card. Then it'll try and load mode 13, which is like the 320 by 200 mode. Then it does all of this horrible stuff to turn on like unchained mode and planes. So that's, and yeah, by doing that, that's how we get all the extra memory for like double buffering and stuff. And then the new piece of code that we're going to need to do here is we're actually going to need a no, we don't. I was going to say, do we need a function to like convert from like 8 to 6-bit? No, we can just do it. We can do it ourselves. So we'll go for int I equals 0, I is less than 256 times 3, I plus plus. Actually, we'll just say 256 because we know it's. Yeah, that'll do. And we go VGA palette I equals PT sys palette I. I didn't mean to shut that, but DOS VGA. Yeah, okay, and yeah, that'll convert it from 8 bits per color, which is what you get normally, to 6 bits per color, which is what you need for VGA, because that's all it supports. And then all of a sudden, now I've done that, we don't need any of this. That can all be removed. Yep, that's all good. Oh, I should probably add an API to like get the palette, right? That sounds like something that'd be smart. So we just go like pt get palette, and that will just return the system level palette. Yeah, and they'll give us like they'll give us eyes on whether or not we're doing the right thing. Yeah, I think that's about right. Okay, hopefully, yeah. So the other risk though is because this is C, and I think that we only defined like 16 colors, is that the rest might be filled with garbage. I hope it's not. I think because we define... No, that's right. I think we should be okay because what we do when we define... So like here's the system structure which contains all the drivers. And we define it here using this, which I believe... I believe doing this means that it tries to fill it with zeros. Though at the same time, this wouldn't be the first time that I'm wrong about a C-related thing. But I think that is like a C99 way of saying just fill this with zeros. Because, yeah, that turns out that's a common thing that you want. You generally don't want to have garbage in the memory. Something that the C, the people who made C didn't really consider was, a priority back in the day. But we don't need that. We don't need that anymore. We've got that. So there's this. Now I think, yeah. Oh, we need to change this. Okay, there's this code here which loads in the palette. Load palette color. Yeah, that's right. And that'll like change what's in the VGA palette based on if we give it a new color or not. I think so. Yeah. And then okay, index this. Yeah, okay. So part of what we would need to do here oh yeah, okay, and we've got this dingus here. We got to move that into here as well. So we just go int palette top. Oh, that's right, and I have the conversion already. So this can go all the way up the top with all the junk. This is essentially a lookup table which converts 8-bit to 6-bit, and it does. It's almost the same as doing just a shift, except it does a bit of rounding. So you can see here like 0, 0, 1, and 2 round down to 0, but then 1, 2, etc. like they round up, and it's marginally better. Marginally nicer than the other way. At least I think so. So we got that, and then we need to go down to remapping that. Actually, maybe what we need to do is we need to just use the function. Like, we've got a function that, yeah, okay. I'm overthinking this. What we should be doing is this. Oh, wait, no, we can't, because this is just the initial load. I was thinking, we could just reuse this and then set up the palette and everything, but technically we don't want to do that because that'd be doubling up work. Okay, so we've got... Yeah, alright. Is there any other spots that's used? No, there isn't. Okay. Oh, that's right. And in main, we need to change that as well. We need to go through, change this, and pt sys palette top equals yeah, that'll do. Okay, then I'll sort that out. Now there shouldn't be anywhere else that's using VGA palette top. Okay, all of that. So let's see if that builds. Nope, doesn't, because what? Why is that having a? Why is that screwing up? Oh, because I I fat fingered it. That's what I did. I fat fingered the timer code. Line 90? Oh yeah, yeah. That's not good. We need that. Make. Okay, that's so we can quit this. Oh. Oh no, that's in Wacky Wheels. Yeah, why would that work? Okay. Yep, seems to be fine. We can check the log to see that the colors and everything have been remapped okay. Yep, it's still loading in the palette colors after 16. So okay, we've removed that dependency on VGA palette. So I think that means that we should be able to kind of, yeah, so that now means that this can be whatever slop we want, and then as long as we have a function which goes ahead and converts it back into like to nice colors, doesn't matter, because that's no longer the source of truth. This is now the source of truth. So okay, and let's quickly do this add in like this get palette API call, because that's rather easy. So yeah, the majority of this engine is written in Lua rather than C, mostly because C is terrifying, but at the same time, it's a little slower. But for all of the actual like game related stuff, so like I'll just show like a little example of like what the game related code is looking like. Yeah, it's very kind of high level. Like this API here is all Lua. It's all documented, and it mostly is written in C. But yeah, like we're you know we'll get, you know, basically once we've kind of like all of the technical bits of the engine are kind of like singing and dancing, then we can focus more on like the dialogue based puzzles on here. Or, you know, not dialogue based puzzles, but you know, the actual kind of game logic-y based stuff. But to do that, we gotta do a little bit of spade work. Right. So here, yeah, script.c contains all of our C to Lua glue, essentially. So we would need to add in another function here called pt get palette. And that would come over here. So it would essentially be, I think I need to look at the Lua manual. Lua. Because, yeah, in Lua, you get... everything's either, like, kind of a primitive type, like an integer or a float or a string, or it's a table. And a table is, like, a mixture between a list and a dictionary. So what we want to do is we want to push every color index, so, you know, every color RGB, and we just want to return it in one big table. But... the API for tables is kind of a bit weird. Lua create table. Okay, so like I think this is what we need to use. Create a new empty table and pushes it to the stack. Parameter nar is a hint for how many elements the table will have. Parameter elnrec is a hint for how many elements the table will have. Okay, yeah. So I think if we could just create a table and then I believe there is another function which allows you to just add stuff or like append stuff to a table. So we'll go down that route. I think we'll just we'll see how it goes. We'll go Lua pt get palette. So we'll go Lua create table L. We know it's going to be 3 times 256. Other elements 0. Okay, that pushes that will push a table on the stack. We want to return 1 because we're just Lua. You can return multiple things. In this case, we just want to return one table containing all the stuff. Now, I think we would need we need a loop for int I equals 0. I is less than pt sys palette. Top. Because no point in returning like the big empty swathe of the palette. May as well just return just the colors that we're using. So I think that'll help. Now, actually, I just want to quickly check. Okay, yeah, okay, so that's a multiple of 3. That's fine. So we go... We could return like one table per color, but that would kind of be slow. I'm not sure I really want to do that if we can avoid it. So palette 3 times I. So push. So for every color, we're just going to push the integer that contains the color, and then okay, there we've got lure concat. So it concatenates the end values at the top of the stack, pops them, and then leaves result on top. No, I don't think it's concat that we want. We want insert, yeah. Oh no, that's moving stuff around in the stack. Lure L. It's like creates and returns a reference. It's got to be here somewhere. Come on. Table.insert. Like there's table.insert, which is the lure function for doing it. I thought there would be like a shortcut in C for doing this. I mean, we can ask the internet. Lure C API table insert. Because the copy of the lure docs that I have here, they've had problems. They've had problems sometimes. Oh, set field. Okay. I think set field is what I want. Does the equivalent to tk equals v, where t is the value at the given index and v is the value on top of the stack. I think that's right. Yeah, that'll do. Yeah, I think that'll work. So we just go lure set field L, and then -2. Oh no. That's not what we want. Oh, set I. Okay. Set I. I think it's set I, yeah. N is the value of the given index, and V is the value on top of the stack. This function pops the value from the stack. Yeah, okay. So then this becomes I plus 1, because in Lua, arrays start with the number 1, not the number 0. So don't fall for that mistake. And I think that, oh yeah, we got to do this 2 more times. I plus 2, I plus 3. Okay, and that should give us this. Yeah, all right, and that should, from inside Lua, give us access to the palette. Because essentially, like, it would be really cool if we could do things like palette cycling and palette fades and like all the other kind of like Old Testament graphicsy kind of things. But at the same time, I want to be able to do that from Lua. I really want to keep C out of it if possible. So yeah, it makes sense to kind of add Lua hooks for doing all of that. So if I start this up, we can now use the debug terminal that we've got stashed away here in so now I should be able to go pt get palette. Hey, look at that. So here, well, okay, it didn't work, but we got something. Okay, so my maths is bad. Oh, I think I know why. Wait, did I? What? Oh, yeah. My maths is bad. I forgot to do this. Forgot to add that in. So it's actually 3i plus 1. Oh no, it's 3i plus 1, 3i plus 2, 3i plus 3. Yeah, because it will always be off by 1. Oh, Kinnico says, my maths is the worst. I cannot enter maths. I mean, I can do maths. It's just, I will admit, it's harder to do on stream. Like, the few times I had to do maths on stream, I just kind of like, I don't know, stare slack-jawedly into the middle distance for a long time. Maybe kind of like breaking it down into like very basic kind of, you know, kindergarten-esque type things that my streamer brain can deal with. But yeah, it's just, it's made a little bit more harder in DOS, especially because I can't, you know, all I have is print statements. I cannot debug it to see like where the maths is going wrong in the middle, which is what I'd normally do if I was doing stuff with like ScumVM, for instance. Like, I rely a lot on being able to like probe in there. Okay, so we've got the EGA colors, but I think that because I didn't include a little something in here that sets the... Yeah, okay. I should have actually gone through and gone pt sys palette 3 times idx equals... Yeah, because I didn't set the color here too, which is what I should have done. +1, +2. There we go. So now we've got all of the colors that have come out of what we've rendered to the screen so far. So that's good. Let's add some checkboxes for all of this stuff. Excuse me. Oh god. All right. Done. Got that one done. So, this thing here, this freaking thing here, maybe, okay, because like, the order that we need to do, in order to change the palette, we would need to set a flag, erase all of the hardware images so that they get recreated. So we don't need to recreate them ourselves, like the blit process will do that next time that they see them. Like we could have some kind of hook whenever we create images so that they get added to a list for eventual cleanup. Yeah, maybe that's the way to go about it. Okay, but that's after. So let's set a clear flag. We would need to change the palette remapper. Then we would need to have some kind of process that goes through the system palette and crunches it down to nearest EGA plus dither. Then sets the VGA palette actually no, then we don't need to do because EGA is already part of the stock palette, we can just reuse those. But yeah, okay. But we need some kind of table, I think. We need some kind of table for keeping track of all of the ways that we're going to ruin the colors. And that'll be separate from this, and that'll be where like this API comes into action. So what would something like that look like? It would look like a little something like where'd the palette go? Oh, it's up here. Okay. So we'll go. Would this be a struct? How much information is there? Yeah, I think it would be. Yeah, it would be a struct. So struct pt dither and then we go enum pt dither type dither d50 I don't know, I'm just inventing names. Just inventing names for these. So we'll just go dither none. And then we'd have we could have like R1, G1, B1, and R2, G2, B2. And then, yeah, like that would describe I suppose like the question there is like, would we actually describe the full color in here, or would we just use a palette index? I guess the trouble then is that like if you don't have, oh no, I mean, because the, oh no, because the palette index is going to refer to the system palette, which is not going to change. So we could probably get away with like color 1. Hey, Bloody Cactus. Bloody Cactus asks, are you dithering to nearest existing color or a new color? So the aim is to add EGA support. So what we're going to want is something like this, where it dithers to the nearest one of the EGA 16 color palette, and then we can use like a variant of that to get CGA working as well. But for now essentially like dither isn't meant to describe colors outside the palette. It assumes that the colors are defined somewhere in the palette. It's just, it just allows you to override an existing color with a dither pattern based on one or two other colors. Sorry, it's got to be two other colors. What am I saying? So we'll just say IDX-A, IDX-B. Because I don't think there would be there wouldn't be a case where you would want... Yeah, there wouldn't be a case where you would define it in terms of a color that isn't there already. Like, at least for EGA and CGA. Essentially, you probably wouldn't use this in VGA mode, except for, the way I see it, it would be nice to have the ability to turn on dither in VGA mode, because then we'd be able to, progressively go ahead and, see, go ahead and, hand tweak how the colors looks. I don't know, the example that I gave was, this background, that's fine for dithering. Dithering is fine in the background, but, the character sprite here, I don't want to have dithering by default. I want the ability to be able to say, I want the clothing to have to use the two blue shades and that's it, and ideally very little to no dithering. And yeah, the way to go about that, I think, would be to offer the ability to manually override this. But I think that as a if we offer the ability to override this for every... So, okay, we'll need a few different types. So we'll have none, which basically means don't apply a dither. And I think we'd also have dither fill, which would just apply IDX-A. I mean, we could have fill A and fill B. And that'd be your 0% and your 100% dither mark. And yeah, then we'd have I guess a bunch of methods for, we'd have methods for kind of defining custom dither patterns. But for now, we can just get by with these. So yeah, I'm liking how this looks. We'll go dither none equal 0, so it starts from 0. It doesn't matter what the rest are. And then we've got a definition for PT dither. All of this should really shouldn't be here in the VGA driver. We'll move it out later. Doesn't matter. We're just prototyping. And then we'd be able to have static PT, and then we can go type def struct PT dither, static PT dither 256. And we'll go VGA dither, 0 it. Okay, and that gives us our storage for this. The API will still accept full color values, because we'll convert that on the fly. And if it's not there, we'll add it into the palette, I think. Actually, hang on. We've got this one which loads it into the actual hardware. Oh, map color, yeah, okay. So map color will return the palette index. Yeah, okay. And I'm deliberately trying to avoid API calls and such which use palette indices, because the way that the engine is set up, like, ideally I don't want people to have to worry about the palette. I just want them to be able to like load in images and then like the palette is taken care of. So from it's, you know, there's a very tiny amount of overhead involved in like converting an RGB color into a palette index, so we'll just do that all the time. Hey 32-bit kid, yeah, we're thinking of ways of like how to add in like a dithering, like an automatic dithering component, so that we can then downgrade these graphics to glorious EGA or CGA, like CGA. But yeah, like for now we're just doing it inside the VGA driver. So then we can have like, once we have like these methods implemented, like, you know, creating an actual thing that runs in EGA, you know, in EGA space or CGA space, that just becomes like maths as opposed to all, you know, we're doing like the actual kind of spade work here. And more importantly, because we can do it because we're doing it in the VGA driver, it means we can prototype and like test and see how the graphics are going to look as an EGA palette. So, all right. So I'm happy with how this thing here looks. I think that what we would need to do is start porting over this Python code for getting the nearest EGA color, or at least getting the nearest color in a list, which I think is what the stuff is going down there. So let's make a new this seems important enough that we should probably make a new C file for it. So we'll go touch color.c color.h add. Okay, and then we can just like keep the VGA specific stuff trapped in there. And I'll open up my Python code in this other tab. Okay. So let's just do some quick and nasty Python to C porting. So we're gonna go float gamma to linear, and where n is also a float, I think. Okay. Import, sorry, include math.h. Is it just PAL? C PAL. Oh, okay, we want to use PAL F. We don't want to use double. Double's really slow. Also, we don't need that level of precision. It's just colors. No one's gonna get angry. Gotta change this into like being a C style conditional. No, not that end. Anything but that end. Float. Do I have to put F after all of the numbers? Is that how you kind of... No. I guess not. Maybe I misremembered that. And then delete this. Yeah, alright. So we're going to need some structs, I think. Struct. Hey Mac, how's it going? We're deep in the guts of some color dithering code. Now, I don't know. This seems pretty small, right? Like, I don't know, would I go to hell if I just passed that as the output of a C function? Would that be so bad? I suppose I could pass it in as an argument, which would then mean that we wouldn't need to pass it on the stack. Yeah, it's it's tempting. It's tempting to just do that. What's CBRT? Oh, cube root. Okay, yep, CBRTF. Oh, that's good to hear. Love some big chillin'. I don't know. Yeah. I have to admit, like, converting. I do like prototyping stuff in Python, and then just the process of converting it to C is just like, it's fairly mindless. It's just like a nice kind of meditative process of like, oh, I just need to convert these things to these things and such like that. So let's go. Oh, that's right. So we've got one struct here, which is going to be our RGB8 color. RGB. And I also got to include standard int. 32-bit kid says, I think you can suffix them with the F to make the compiler make floating point literals rather than double precision literals. Oh, right, okay. Like, yeah, that's what I wasn't sure about. I couldn't remember if, like, I know that you could add this, but I couldn't remember if, like, that meant that they were treated as double precision literals, or if, like, the compiler was smart enough. I'm going to assume that the compiler is not smart enough. That's probably a good idea. But let's go ahead and do that, because, yeah, we don't need... I mean, this code isn't going to be run all the time. It's only going to be run like during that initial like palette calculation pass, but it's still, you know, pays to be kind of tidy with your floating point code, because, you know, DOS ain't that quick. Right. Now C, so then go, C would then become PT color GB. So we'd pass it in as a pointer. PT color, okay, lab. Dest. Then we can change this. And we'd also need to, oh yeah, that's right. We would need to convert this into floats. I think I think that's enough to upcast it to floats if you just multiply it by another float. All these are going to have to become floats. And these, oh yeah, they got to be floats. Absolutely got to be floats. And then we would need to change. Oh, that's right. An OK Lab uses a different. It doesn't use RGB. It uses something else. Did I open it up? I opened up an OK Lab tab, I thought. That's CGA. We were looking at that before. Yeah, okay. L, A, and B. Okay. I think. Yeah, okay. We'll just call it L, A, and B. Oh, and these would be pointers. Oh. Yeah, we can get rid of the type notations. Oh, and we need semicolons. Yeah, I guess. I guess we need semicolons. There. Happy? Is that enough semicolons? Ah, 32-bit kid says, in most compilers there is also a compiler flag to treat all floating point literals as single precision rather than default into doubles. Yeah, okay. Yeah, I would... Makes sense. Makes sense. But yeah, for brevity's sake, probably best to... Actually, what am I saying? This is the less... this is the least brevity way of doing it, but it doesn't matter. Verbose. Let's just be verbose. Yeah, exactly, 32-bit kid. Like, science has yet to discover a way of telling, like, when the next command starts without one of these little guys. Like, this is unsung hero. Like, Python, they're just bluffing. They're just bluffing half the time. So now this becomes pt color OK Lab source pt color RGB dest. Oh, is this... Ooh, that's right. Is this the case where, like, because we're in C, we don't get min and max? Oh no, we get F min. But, like, this is kind of like a baffling omission in C. It's like, Okay. I'm gonna double check this because it's like, of course they'd have like a floating point version of doing it, but they wouldn't have an integer one. C min and max integer. Oh no, they well that's C++. Of course they added it in C++. Yeah, where are min and max defined in C at all? They're not. Yeah, alright. Fine. Fine. Oh, that's because... Okay, so... We've got this kind of clamping... And that, yeah, that's just kind of clamping it between 0 and 255. Macros with nested ternaries for the win, yeah. Exactly. You know what the score is. Okay, does the CMath library have a round function? It does. L round F, I think is what I want. Rounding halfway cases away from 0 is to return. Yeah, okay. So we could be sneaky and just do like F min and F max with the floating point one, and then at the end just round it. I mean, but yeah, like absolutely baffling omission. Like, how many revisions of C have they had and they just never thought, oh, it might be nice to have like a standard library function for comparing two integers. Oh my god. Anyway. Not gonna get tilted at like weird C decisions. Source L. Okay, that then... Right, and then what do we do? What do we do with this? Yeah, I think, okay, we'll use F max F and F min F. F max F 0.0. Then we'll remove the round and we put that on the outside. So it then becomes L round F. Oh. Thoshibika says, I love you making the hop through OK Lab Space for DOS game. Well, you know, gotta... many innovations have happened since like the last time that I don't know, since the olden days. May as well do like an equal brightness type transform. Because yeah, we want all the best modern conveniences here in MS-DOS. Okay, I think that'll do what we want. So if we copy this 3 times, GB, this becomes I, R, and T. Oh. Wait, is that... Oh, not enough brackets is the problem. Okay. So that's converted those two. We don't need any of this. This was... Okay, that was the original JavaScript, which I ported to Python. Oh, this is like the broken code, which I initially tried to do this based on like the algorithm, and then I eventually gave up and just kind of borrowed these functions that I nicked from a website and ported them to Python, and turns out they worked a lot better with fewer errors. So thank you very much. Products eptimize.app. You did a good color converter, and the JavaScript was readable. So points all around. But yeah, all of these are nonsense. Don't trust them. We will need a color blend, I think, because this is the function that we use to determine. This is how we kind of like blend 2 points together in OK Lab space. So we'll go void OK Lab color blend, and then we'll have a PT color OK Lab A, PT color OK Lab B, float alpha, then PT color OK Lab dest. And then we basically just have to go through and go dest L equals very basic. So we, it's just linear blend between two colors. But because these coordinates are in the OK Lab space, like the idea is that compared to RGB, like if we go back to like this test image here, so like in RGB space, when you kind of like do like a hue saturation transform, you see all these color bands because like despite the fact that it's like a different hue, the brightness is different. Whereas in the OK Lab color space, the hues are all the same lightness, basically. So it's like a more uniform kind of perceptual brightness. 32-bit kid, you got it. So that's why we're kind of going to all of the hoo-ha to do everything in OK Lab space when we are doing color matching. So that's our color blend function. Now here's the actual meat of here's the actual meat of what we need to do. So we've got all this stuff here. We've got all these like assistance functions. Now we need to tie it back into this stuff that we added in the VGA driver, namely the I made a struct. I made the damn here. This dither struct. So for now, we're just gonna care about like dither D50 or dither fill A. I mean, like, so like the thing, right, is that despite like these dithers can correspond to any pattern. It could be like checkerboard, it could be like grids, it could be like waffle shaped, doesn't matter. But essentially, like, there'll be some pixels which are some percentage of pixels which are color A and some percentage of pixels which are color B. And that's what this alpha value is here, because, you know, it's really just counting that, like, it's counting for the dither to say, like, you know, for checkerboard, right, you know that 50% of the pixels are going to be color A, 50 are going to be color B, which is, so your alpha is going to be 0.5. So half of one, half of the other. That's going to be a blend. For, like, everything that's fill A, then your alpha is going to be 0, because it's focusing entirely on color A. You know, opposite for B, and then, you know, stuff like that. So yeah, so we've got this, so we have these methods. We have these methods that we've put together. We just need a method for, like, I don't know, for now we can just kind of, because we're prototyping, we could just we could just kind of like glom it in so that, like, no matter what color we pick, it will try and get the EGA equivalent. And that'll at least kind of show us if it's working. And then we can split it out and turn it into, like, those API calls. I think that's maybe the way we'll do it. Yeah, so I've got blit, flip, load palette color, load VGA map color. Yeah, okay, so, like, this is kind of close. And, like, here we just, like, here is sort of doing what this is doing, except it's just kind of getting, yeah, like, it's doing, like, yeah, this is kind of like doing, like, a very cheapy nonlinear transition to determine, like, the color distance. So it's like a less, you know, it's a cheap and cheerful version of, like, what we're doing here by transferring through the OK Lab color space. But I don't think that that's where we would do it. I think what we would do is that we would have, like, we've got our map color function, and as part of the process of adding a new color, we would go through and, I guess, we'd add a dither entry. Or firstly we determine what the two colors are. We determine, which would mean, so yeah, like, okay, the mapping here, right? It would basically be like, for every combination of two EGA colors and a dither, we'd get the nearest color in RGB space. No, maybe I don't want to do that. Maybe that's too much. Okay, gotta write this down. Okay, so, like, crunches it down to the nearest EGA and dither. We have a palette that has all of the RGB8 colors. We need to get a list of that's it. We need to go, okay. PT dithers, which remap these to the two EGA colors plus a dither mode. Then finally, when creating the hardware image, we need to consult the PT dithers table so that we can draw using the dither if required. Okay. So those are the parts that we need. So part one is that we need to generate this table. And for now we'll just assume that it's always going to be this. It's always going to be using the EGA colors. So how do we go about doing that? For now, I'm going to actually move this to the color.c, because that makes more sense for it. And then the header file for color.c, that can be the point where we define that. Do I have that in system.h? Oh no, I did. Okay. I did put in some guards. Oh. Here's where I need to put in the okay. Include color.h. Yeah, all right. We need to consult PT. Okay. So back here in color.c. Big generator. Hey, Summer B76. Yeah, it's all going on at this point. We're in the middle of trying to like figure out how to turn good colors into EGA compatible colors, because VGA is really expensive. No, not everyone can afford VGA. So like Sierra knew this, Apogee knew this. Therefore, in order to be like properly worth its salt, our adventure game engine needs the ability to downgrade the graphics to EGA. EGA at a minimum, but maybe CGA at a stretch. So yeah, we're just in the middle now of kind of like adding in a we're converting using OKLab, which is like a much nicer method of like blending between colors, which doesn't result in banding like kind of normal boring HSV does. But yeah, the thing that I'm kind of like we're trying to kind of architect now is related to dither patterns, because obviously like in order to kind of like look nice, we at the very minimum want like checkerboard dithering like this. But in order to calculate that, we need to basically have like the palette with the good colors in it, and then a second palette which has like overrides, which converts to like the nearest EGA checkerboard equivalent if necessary. So that's what I've written that all out in Python, and I'm now just porting that to C. So like, I think that unfortunately, like C limits like the amount that you can just kind of like plop into the source file by hand. You need to be able to. You probably need to put it in a function for it to be any use. So all of this stuff here I think is going to have to go into a function. And how do we... Yeah, okay. So let's just prototype it in a function. So we'll go void generate EGA dither list. Okay. So so I think probably the easiest way of going about this would be, yeah, we'll just use malloc for now. That's fine. There's no sin in using malloc. Like basically once we've prototyped it out, we can go back and like make it static and less I don't know, less bad. So gonna include standard lib, I think is the one which has it. And we'll go size of, actually no, size of EGA palette, size of float. And then we would just basically go for 16 I plus plus I think that's allowed. It's a little kind of, I mean, would we go to hell for that? Would we go to hell for like treating a pointer to this as the same as like a pointer to an array? I think it will work. It's fine. Try not to think about it too hard. Yeah. All right. Just go RGB 8 to OK lab. Like there's a chance, there's a slight chance that I'm gonna get done for like memory crimes, like memory alignment crimes. Because I think that like it'll try and it's gonna, oh, okay. Yeah, I think that like what I was thinking was like, hey, if we do it this way, then we don't have to worry about like we could kind of like double this up and have actually what am I saying? We don't have to have this as like a list of bytes. We could have this as a list of these PT color. Okay, and that'll get rid of the stupid alignment problem. Yeah, okay. Changed my mind. So this now becomes PT color RGB EGA palette, and then all we need to do is add in brackets. At least I think we can do it this way. Doesn't need to look good. I'm running it through the code formatter later. There we go. That's valid. Valid maths. And then now this doesn't have to be float either. It can now be PT color OK lab. And then we'll just say that it is now 16 because we know it's going to be 16 and we're doing it. There we go. This is nice. This is much nicer. EGA palette I, EGA OK lab I. Okay. So that gives us our I better free it. Oh. So we do this. Yep. So the so the kind of the slightly nasty way that I went about generating this kind of conversion chart. I know, like here, like so, like here's the original. Here's the original, which is in like 24-bit RGB. And you'll notice that the convert and like when I did kind of like the naive way, what would happen is that it would kind of realize, oh, if I take like light yellow and then combine it with black, then that provides like a really nice like halfway spot, which, you know, mathematically kind of may have a point, but it just doesn't look very good. Like there's a certain point at which like the eye is drawn too much to it because the two shades are too far apart. So here I deliberately kind of like take out or I prevent black and black from matching with all the lighter EGA colors and white from matching with all the darker EGA colors, because those blends they don't look good. They don't look good for automated blending. Gotta trust me on that. Yeah. And that's right. And so the kind of the nasty way that I did this was just putting together like a very basic matrix of like every single color paired with every other color and then notched out these combinations here. Third Certificate says Sierra Onliners would definitely disagree with that assertion. I don't know. Like I was looking at Conquest of Camelot before. Like you can see here that like they pair like the dark black with dark magenta, and like there are some combinations which work really well. Like you can see this kind of like white and yellow like works really well because they're kind of like two blended together. But like most of the time when you look at like the dithering in like the EGA era games, why are we looking at the Atari 2800 one? Oh, this one here. Yeah, okay. So the light gray I think is, yeah, okay. Light gray is kind of pushing it a bit. Like that wouldn't have been allowed under the because yeah, technically I didn't allow that. Maybe I should allow that one. But when you kind of like look around, you're like, yeah, it's very like for like for most of it. Because yeah, like anyway, doesn't matter. We can adjust. We can adjust if need be later on. Oh, they do it pretty often, but they sometimes use it for texture rather than color fidelity. Oh, okay. Maybe I just don't remember seeing that often. Like, specifically like white merged with like the darker range colors and black merged with the lighter range colors. But anyway. Gotta trust me that it looks weird and it needs to be a deliberate choice. I don't know. I'm hemming and hawing as to whether or not I should actually just go ahead and calculate. Okay, so what have we got? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8. What's the math? What's the math on this? If we go back and look at those, look at the colors. Screw it, math's too hard. We'll do all of them, and then we'll do literally exactly what we've got here, and then come back and come back and maybe do it a nicer way later, because yeah, it's fine. So we'll go 256. Uh, 32-bit says, looking at you, Codename Iceman. I mean, there's some, I don't know. There are plenty of nits to pick with Codename Iceman. I'd say that the graphics, I quite like the graphics in Codename Iceman. Just a shame about like all of the all the submarine bits and the racism. EGA halftone. Yeah, okay. We're again deliberately not thinking. We're just gonna do it the cheap and dusty way. So copy this. 256. We are literally just gonna convert so we're just combining every single okay lab color possible. 0.5 F and okay, that'll create loads of OK Lab colors for each of the halftone combinations. Then we're going to add in these notch filters. Sometimes I do miss copy constructors from C++. Like, it would save a bunch of time, but it's probably for the best that we kind of can see up front, like, how much time is being wasted by the CPU copying stuff, so I can appreciate that. So that becomes... A, B. Hey, the fungi, the real, yeah. doing DOS programming in NVim exactly as God intended. No, do whatever you... It doesn't matter, just use whatever text editor, like, you can be more efficient in. I don't know. I've had, like, the piece of brain removed, and for whatever reason, NeoVim works best for me. So, that's what I'm using. Oh, God, I've got it wrong as well. So we go int j equals light. And then this should be j. This should absolutely be j. I less than or equals size of dark. Oh, and NVim sucks on Windows. I'm sorry to hear that, the fungi. The real, yeah. Is it just kind of like down to like Unixy type things, like just POSIXy stuff, like file system access not working properly? But yeah, like at the moment we're just kind of porting all of this, porting this color conversion code that we've written in Python into C, because right now our engine supports VGA, but really what we want to do is be able to downgrade it to EGA, which means converting it to use these kind of EGA dithered fills. So that's what that's what we're up to. Oh, just normal NVim? No conf file is accessible. Really? Like, I thought, isn't it just in like app data or wherever Windows applications like dump their junk? I don't know. It's been yeah. It strikes me like surely there's got to be something. Yeah, that's right. The 32-bit. I absolutely don't regret my choice of words. It was all deliberate. So that's B. That becomes A. Becomes A and yeah, okay. Yeah, looks about right. Then we just need to change this. Right. So we've done that. Now we need to get a halftone mixing palette out the other end. Yeah, it should be here. Oh, okay, of course, we've got to malloc another thing. Oh, yeah, sure, alright. And this now becomes PT color RGB, 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 RGB. And then for int I equals 0, I is less than 256. PT, OK lab to RGB8. And these become addresses. Right. So at the end of all of that, we have generated this lookup table, which I mean, like, so in actuality, we probably could like generate this lookup table ahead of time for EGA and just use that. But there's technically nothing stopping people from using this for VGA colors as well, so maybe it's better that we just compute it all and see. Okay, now we've got that. The next thing we need to do, so we need to... Yeah, so now we need to kind of like generate this PT dithers list based on this EGA halftone map. Return EGA halftone RGB. And now I'm thinking whether I should like redo the system palette to use PT color RGB. Probably should, but we don't need it just yet. Okay. Yeah, just never-ending mallocs. That's the C guarantee. Okay, now generating this thing. Now that we've got color, like maybe it makes sense to maybe move this dithering stuff into color. That makes a bit better place for it, I think, than the VGA driver anyway. So if we move this up here, and then and we want something like void get dither for color. Doesn't matter. We can just pretend that we're and we just go PT color RGB EGA dither list PT color RGB source PT color PT dither dest Okay, and then this will be kind of abusing the fact that we know it's exactly 256 things long, but we can change this later to. Actually, no, we'll do it now. Int size t. Actually, no. What am I saying? This methodology is only going to work for EGA because we're only measuring like the halftone dither. We might have to like come up with like a better way of pre-computing this stuff. I mean, no, dither is always going to be between two colors, so we can pre-create lookup tables for like all the different types of dither that we want to use, and at worst, there will only be 256 entries per table, which, times 5 or whatever, how many dithers we got. That's not too bad. But for now, we will just do this. So and it doesn't matter. We can, because we're being kind of cheeky, we can just assume it's always going to be 50 dither, like a 50% one. So we go dest type is always going to be dither d50. That much we know. Then we need a kind of, I think we need a. How do we do it in here? Do we need to? Yeah. Oh, right. Okay. Did I have? Oh, okay. I need to create this. There's one other function that I didn't add, and that is float. Okay, lab distance. Oh, okay, and that's all going to be replaced. I can't remember what the syntax is for like just replacing all the ones on one line rather than the entire document. So, and the time it would take for me to look it up is probably the same amount of time it would take me to do the copy paste, if not less or more. So we'll just do it this way. Okay, that gives us our distance function. And now I realize maybe what we want is because this is kind of a lookup table, we just need the OK lab one. We don't need the RGB one at all, because we're doing distance comparisons in OK lab space. Oh, Bloody Cactus says, I need to get off my butt and work on the December 2024 intro. I've been too busy working on my adventure engine Priority is not my strong point. Oh, you're working on like do you mean like a demo scene type intro for December? That's kind of cool. Like, was there one last time? Like, I don't know. I participated in December, but mostly just to play like Cocktail Vision games. I did not know that there was like some kind of like ceremony or contest or thing like that. Okay, so let's assume that we don't need this. We don't need to make an RGB version. That can get in the bin. We can return the OKLab version, which then means we can then make this OKLab EGA dither list. Oh, can you link to it in chat then, Bloody Cactus? I'd love to see it. Because yeah, I missed the 2023 one. So but yeah, by all means, link to it in the chat. Okay, so we got all those colors. Then the actual meat of checking would be this. So then we would go PT color OKLab OKLab I just want to look at it now. I want to look at it now. Oh, it's got an ad-lib tune. Yeah, okay, we're definitely looking at it now. Oh, cool webpage too, gotta say. It was DOSM23. Okay. What? No, don't download that. Oh yeah, that's the good stuff. Little bit of scroll planing, little bit of parallax. Oh, and it changes. Do you know that some really amazing Twitch teams are doing a December awesome event this December 2023? Called December, where we play old retro DOS-based games. We wouldn't know about that. Browse the Twitch retro category for streams with hashtag December. That's smart. Like, I didn't kind of know this at the time. I know now that, like, apparently it makes more sense to stream with the retro tag on Twitch than to just, like, tag the individual game you're playing. Like, I do like the idea of being, like, the only, you know, being listed as the only person on Twitch that's, like, played, I don't know, like, normally the stuff I work on is, like, old director games. Like, the only person who's played, like, Shelley Duvall's It's a Bird's Life or whatever, but I can also understand, terrible for discovery. Like, most people just, like, open the retro category and, like, see what people are doing, so yeah, I really wish that you could have like multiple categories selected in Twitch, because yeah, you know. Oh, 32-bit kid said, I had it running on a Packard Bell 486, but I wish I had a real CRT to see it in all its glory. Yeah, I regret like selling my last CRT like a decade ago. That turned out to be like a bad idea, but yeah. I do have like my Pentium laptop over behind the desk, with a fairly glitchy screen, but I don't know, that's kind of what I've been using to like check my engine builds with, and I'm actually kind of quite surprised like how well like it works in Windows 98, like just with basic DPMI support. Bad idea, you have to lift one. Yeah, that's why you just get a smallie. You don't need to get like a massive one, just a smallie. Though to be fair, that's probably the reason why I sold my other one on Gumtree, just because I was sick of it taking up like closet space. But yep, now I've got a ton of room, and it's like, kind of wish I didn't have to give that away. But you know, it's how things are. When you live out of a shoebox, you got to make some sacrifices. But oh, like so the shout out list was like all the people on the streamer list, huh? Okay, yeah, maybe you're gonna have to get like one of those what do you call like the demo scene kind of like wavy scrollers, just like the infinite wavy scrollers. You know, I don't know, they're amusing, but at the same time like impossible to read. So maybe don't do that. Maybe don't listen to me. What have we got? So. Alright, so we have our source color, we have like our temporary OK Lab color. We then need to go RGB 8 to OK Lab source to get the OK Lab equivalent. And then it would just be a case of like, oh yeah, doing this kind of nearest val thing. So we basically go int nearest equals 0, float nearest val equals OK Lab distance source OK Lab, and it would be the first color in the EGA dither list. Start it off, and then it would be for int I equals 0, I is less than or equal to 256. Actually, no, it would be 256. It would be n. Officially, that's what we're saying. And yeah, then we just check. New val equals OK distance yeah, that looks about right. We go if new val is greater than nearest val equals new val. So basically just like measuring the distance. Oh no, we want the closest, don't we? We want it if it's less than nearest val. Nearest val will be new val, and then nearest will equal I, which is the index of the color. And then we basically return... Okay, and then based on what value we get back for I, then we can use that to determine the two colors, which would be dest idx. A will be I divided by 16 and percentage sign 16, and that, oh actually no, it will be nearest. Okay, and that is how we get EGA colors for everything. All right. So we've written a bunch of stuff. I'm conscious that like maybe we're getting to the point of no return with our mods here. Maybe we should. Actually, I'll just quickly add color.o to here. So we rebuild that. We'll just make sure that everything compiles properly. Nope, it doesn't. I've made a bunch of mistakes. I included math.h. What are you talking about? What's your angle? I absolutely included math.h. Look, it's there. It's right there. Include math.h or provide a declaration of f-min-f. Like that's, oh no. Oh, because there's another library I need to add, I think. Do I need to add lm for it to include it? Hang on. DJGPP. Okay, so the C, yeah, right. So the C library, the DJGPP C library does not include f-min-f. So yeah, okay. I got. So we don't actually have to do it this way around. Do we just do things the? Because I mean, technically, we don't need. Okay. C macro clamp. Because really, that's what I want. I just want clamp. Okay, say no more. That's going to be our clamp function. Alright, so we'll go float, clamp f, float, float, float. And then we can replace this monstrosity with clamp f zero. Yeah, that seems right. Let's... Much better. So that should... Let's stop that yammering. Iteration 8 invokes undefined behavior. Ooh. How did I cock that up? 120. Okay, it's going to be something to do with like me forgetting how size of for statics works. 1, 2, 4, 5, 6, 7, 8. Sorry, 0, 1, 2, 3, 4, 5, 6, 7. What? Iteration 8. But there's no... I mean... Like, I thought size of figures... I thought that when you do it statically, like, size of doesn't care. I thought it doesn't care. You know what? Well, I'm thinking about this too much. Let's just hard code it. Oh, because of its... Maybe because it's like thinking of it like in terms of size of like bytes. Yeah, okay, that's probably it. That's probably it. That's probably... I mean, we could do it this way. No, screw it. It's a list that we know how many things there are. Unknown type. Oh, because I didn't include color.h in here. Starting to think all of this junk goes in the header file. Maybe that was a mistake. Oh, did I not I did include, yeah. Conflicting, oh, because I defined it. I defined it in here. Okay, so we have this, but then... Okay, so then we have to like consider... Okay, maybe we can't get around it. Maybe we do have to consider using types for this. So if we do that there, and that should cause... And now all these decisions are coming back to bite me, but that's okay. I think that's all the references that we have to that. Okay. Will that build? Okay. It's pointed out that yeah. I should just avoid. I should avoid using size of as much as possible because it only kind of thankfully the compiler is there to kind of just save me from myself, but it's still not ideal. Oops. Oh yeah, and now the API that we made here is not going to work. Cool. All right. Does it still build? Hopefully it does. Hopefully it should. Oh, good. Okay. So colors, the palette code seems to have survived, and we'll just double check with the terminal. pt get palette. Oh, underscore pt get palette. Yep. All right. So it's still caching and fetching things as expected. Now what we need to do is we need... So back in here, back in this dither color function that we made. So if we're doing things kind of the cheap and nasty way, we'll just do it in here. We'll do it in the VGA list for now. Okay, so we have an array here which is VGA dither. Actually, no. Yeah, I forgot where it was. So we've done all these kind of surgical modifications to the color system. I'm just going to commit this. Then we'll go ahead and add in the EGA to the stuff. Is OK Lab spelled with a capital? Oh, it's just okay. Okay, good. And now, because we've got auto formatting, like this looks nice, I think. Yeah, it went ahead and formatted it properly. So, first things first, we got to call generate and so PT color OK Lab. And we got to add our methods in color.c to color.h so that we can see them. For now, we'll just export these two. Yeah, that should be enough now. Then back in here, generate, get the big list of do-the-redos. And then we call this for every, the intent is to call this for every color in the palette. Basically be get EGA dither for color, dither list 256, which we probably should pass out from the generator, but not now. And then the source color, which is PT sys palette I, and the destination color, which, oh sorry, the destination dither, which is going to be that big old list at the top. VGA dither, okay. Okay, and then to kind of force the use of our oh, that's right, and we got to add in a hook into the color remapper so that we generate the dither color as well. And then that would basically be the same as this. And then down in here, we can add in our dither special. So there's this which does the palette map. Pretend we are on EGA. So we'll go, what's the quickest way? Because like we want to do checkerboard dithering, which means we need to do like some kind of XOR, exclusive OR. So if we were to go like 1 + 1, it's just a modulo. We don't even need to do exclusive OR. Modulo 2. Yeah, okay. Let's do that. And then VGA dither. Palette map pixel. So we go like PT dither equals the address of this thing. And then we basically say that the color is y plus x. So we say so x plus y modulo 2 which will either be 1 or 0, and if it's 1 then we want dither rdx b dither x a. And then that would go inside another map. There we go. Now, this will either cause a massive memory hemorrhage because I'll have like forgot to cross an I or dot a T, or it'll just show everything as EGA. Yes. Okay. That's oh, I love this. It's not what I was aiming for, but it's great. Yeah. it's really good. Okay. Okay, so let's maybe unpick what went wrong here. So I can tell that these colors here, they're not in the EGA palette. Yet at the same time, like the dither is only meant to be able to pick between colors in the EGA palette. Like that's kind of we went to an awful lot of trouble to make sure that it was like that. So I think first we're gonna need to like print some more info about this. And that will give us that'll put it in the logs. Hey, it didn't like the memory code's fine. The memory code's like thriving. It's loving it. It's couldn't be doing Okay, so we'll try that again this time. We can look at the log to see. Interesting. Okay, so the dither code, it is picking kind of it is picking colors in the EGA range for dithering. I just don't understand why it's not drawing them to the screen. Hang on. Okay, so it's taking. I see. I see how it is. Oh, wait. No, I mean, what? Oh, right. Oh no, because this is image relative colors, not glow. Oh, okay. No. So the extra palette map, I think we didn't need. Oh, okay. That's better. It's look at that. It's got EGA colors. It looks a bit it's got some kind of like weird, like, yeah, like the oh, you know what this is, right? You know what this is? This is planar. This is some planar magic right here. Because I think what happened, right, is that this code here is doing planar math. So you can see the planes here. You can see like how everything is like blocks of like 4 pixels. That is because as mentioned before, we're using unchained graphics, which means every column, you know, every graphic is split up into like groups of, you know, I don't know how to describe it. Like every 4th pixel is given its own plane, and because I think the math in here, this is it, because we've already split it by plane. So really, all we need to do here, as part of our terrible dithering calculation, I think we just add p. If we add p into here, that should set us straight, I think. Ah, yes. Oh, no, it's still got kind of like a weird sort of. There's still like a weird kind of weird deformation to it. Also, I love the fact that kind of like flesh tone is apparently like equidistant between like bright red and light cyan, which gives it a nice. Don't know if you've seen the film They Live, but yeah, the aliens from They Live is what happens when you kind of stipple things like that. Okay, no, so this is evidently not the right way to go about it. Okay, so which bit am I screwing up here? Oh, it's probably that, isn't it? It's probably that. Yeah. Okay. Because then p plus x gives you the x coordinate. Okay. And I've got, yeah. More brackets required. There it is. Look at that. Look at that. Lovely, lovely dithering. It's, you know. There are obviously some cases where, like, it would make more sense to, like, map a solid color. So, like, you can see there, like, because they picked, like, a weird shade of yellow for the text, it's then thought, oh, okay, like, the nearest halftone color is going to be halfway between yellow and brown, which isn't wrong, but from a readability perspective, we'd want that to just be a solid color. So that would be why we'd want to override, like, the dither patterns, or, like, offer the ability to override those kind of dither patterns. But as a first pass, I'm pretty damn happy with that. Yeah, all right. So okay. So we have this. We have this. So maybe maybe what we'd also need to do is we would need to kind of PT dither just go int 16tx, int 16ty. Yeah, because ideally, right? Maybe I'm overthinking it. Maybe we don't need to, like, make a helper function for it. Maybe we can just do it all in line. Do it all in line and nasty. Because I mean, like, yeah, like, I am initially hesitant because, like, I don't want to put a bunch of, like, common, you know, the hesitation is like, oh, but we're putting, like, common stuff here in the VGA driver when we're going to need it, like, very soon for, you know, EGA and friends. But like, we can do that. Refactoring is much easier than you know, planning ahead of time for things to be right. So I don't mind putting it in here. So if you go if dither type equals dither none, yeah, it'd be something like this. And then Dither IDX A. Yep, still dithered. So very dithered. Alright. Part of me wants to know what this would look like with CGA. I mean, we could just like, we could do a little bit of a sneaky mod to use CGA dithering instead of EGA, but maybe we'll save that for later. So I think what we would, so going back to like our API and how we're going to design it, like my gut feeling is that like this call here, like PT set palette remapper, that would be the thing which generates this actually no, we can generate the dither list all the time, but essentially like that would be the thing that would go in and creates this dither table, and then yeah, essentially like once all this is processed, yeah. Okay, so we've made a little bit of progress, but we've come back into the next kind of barrier that we've hit is in order to kind of prototype like good colors, which aren't the same shade as like the aliens in They Live. We need the ability to kind of erase all of the hardware images. And I guess a quick and nasty way of doing it would be just to add a flag, which is, yeah, like this, create a clear flag, erase all the hardware images. And we can do that by, I mean, we can do that here in the VGA driver. The downside though is that like, if we were to do it here, so basically like every time the VGA driver tried to blitz something, it would first destroy this hardware image if it exists. The downside of doing that is that if we don't show the thing on screen, it's going to cache the old bad palette, which is not what we want. But that might be a case of like perfection being the enemy of good. I'm not sure if this is necessarily like something we really want to aspire to. I honestly don't know. I honestly don't know if this is like the correct decision or not. But yeah. What did I write like an hour ago? Okay, we've got a palette which does this. Remax the two EGA colors in a dither mode. And when creating the hardware image, you control the PD did this table. That's all done. That's absolutely all done. Go through, tick, tick, tick. Oh, and I guess tick here as well. because EGA, yep. Yeah, all right. We'll do it the. Actually, hang on. No, I don't want to commit this just yet because we need to have that API so that we don't always pretend that we're on EGA. But that's fine. We can. Oh, there is another option actually. There is another option. And that is essentially like we can go. And this is probably cleaner because then we don't even have to worry about like garbage collecting. Like garbage collecting, that's, you know, that can still happen. We don't have to worry about that. But what if we went like static int VGA last updated, or we go like something like this, and then when we're converting, oh yeah, we would need to change. We would need to change our struct for the, where's dos.h? Yeah, we would need to change this, and we're going to add a field called like int revision, and then in here we can go, and we just go revision. Nice and thick, and then in our converting function we can result revision equals VGA revision. Then every time something happens to the palette, we just increase. I mean, we don't have really that. Yeah, I mean, for now we can just go VGA revision equals, just increase it. Just increase it. And then like the trick though is that when we need to, when we need to blit it to the screen, when we need to blit a thing to the screen, and when we see there's a hardware image there, else if image hw image revision doesn't equal VGA revision, destroy VGA destroy hardware image. Okay, and then we, up here we can then go so essentially if it's not, if the image is not in sync, then down here it gets captured by that branch. So it'll then create it again if we have not got an image which is in VGA format. So VGA destroy HW. Good. And then all we need to do in order to trigger all of the hardware images being destroyed is just increase the revision. That works. That's nice. That's clean. That doesn't involve keeping track of a separate parallel list of pointers, which could go stale. No, that's much nicer. Okay, so I think we're going to need a new function. We're going to need a new function here in DOS VGA. And more importantly, we're going to need a new thing in our driver, which is going to correspond to the set palette remapper command. Actually, I'll worry about the driver stuff later. We'll just prototype it in here. Prototype it in here as a function, call it manually, then deal with the stuff. So go void VGA set palette remapper. And the out-of-the-box palette remappers that I was thinking of having would be basically EGA and then 6 CGA palettes. Or we could go remapper none. Switch. Remapper case remapper EGA break default break. So actually, maybe it makes sense to have functions in color.c which remap, which do like the spade work of like remapping or like creating those dithers. And then basically all that needs to happen is like during this this function here, instead of calling get EGA dither for color, it will just call like get dither, and then based on whatever the current remapper is set to, then that'll do it. I think that makes sense. And yeah, for now we'll just kind of flesh it out here in the VGA driver, and we'll worry about splitting it out later. So I think it makes sense to have like a function pointer, which we can then point to like one of 6 methods in color.c. Oh, you know, we'll have them in VGA for now, but eventually they could exist in color.c, I think. And then yeah, that would basically mean we'd have like an OK lab list for like, yeah, I guess EGA in each of the CGA options. But for now, so we'll just go void remap sorry, no, void get dither. Set dither. And I guess, yeah, like there's always I mean, like these are just EGA and CGA would just be presets, and maybe later on we provide like a programmatic way of kind of dithering down to a palette for people who want to kind of take that route. I don't know how useful that would be. I'm guessing like that level of dedication we don't really need just yet. All right, so then we'll just go VGA remapper equals. Actually, no. VGA vision case remapper EGA case not remapper none default So none don't auto change the dither. Can be manually overridden. Break. Yeah, okay, so this would then have to change. So that would then go into remapper. Oh, right. So PT sys palette IDX. And that would be an address. Okay. So we've got that function there. Don't need this anymore. Okay, so that would recalculate the dither table. Yeah, okay, that makes sense, because like if we're calling oh wait, no. But if we're calling set, if we're setting the palette remapper, then we want to clear out the dither table, because that's no longer going to be useful to us. But if we're just setting the dither individually, then we want that to be a pass-through. So we'd basically go like if remapper Yep, okay. So we've got that, we've got this. We can make some APIs now. So let's start off with the set palette remapper dingus. So that would be down here. How do we check for strings and that? I'm just wondering how I did like string comparisons, because not gonna lie, easier to do that in Lua than it is in C by like a ton. Oh, okay, I just predefined them in there. That's all right. We can do that. More importantly, we don't need to do that now. We can just assume an integer. So go into color. I can't get over the lovely pale blue and blotchy red skin. It's perfect. It's everything I would have hoped for. So go Lua check integer L. So I'll say int. I'm sorry, enum. This, and then we should be able to call return 0 VGA set palette remapper. Which means we would need to go into system here, add in our function void set palette remapper enum pt palette remapper. Okay. So, if we call PT set palette remapper from inside Lua, it should change the graphics from a VGA to EGA. At least that's the hope. We don't need to get EGA dither for color. What we do need is we need to call set dither. And then by default, that should be boring colors. And then once we turn on the palette remapper, it should be cool colors. Where oh, it's here. Okay. Yep, look at that. Just lovely VGA, right? You think so? Telnet. So we go into here, and then we go PT set palette remapper. Yep, it's function. And if we call it with argument 1, yes! Okay, good stuff, good stuff. Okay, so we can now, on the fly, and we should be able to change that back. Should be able to change that back, I think. So if I then change this to 0, yes, it goes back to VGA. Okay, very good. Super, super good. Okay, all right, we've, so we can tick that off. We've got that API. There's this one here about setting a dither hint, but I'm not sure we need that just yet. Clear palette hints, we can just say, that's also kind of handled by set palette remapper, but we could, you know what, I'm tempted to just leave it as, it's already covered by that. It's already covered by that. And this, again, also already covered by this stuff. So what does that leave us with? What does that leave us needing to do? Oh yeah, we need this API here to manually override a dither hint so that we can start, I don't know, picking some nicer colors that aren't they live coded. So that we can kind of like just go through and like do some nice selections. Okay. But all right. So we'll add in this boilerplate. Now, to do that, we need a function which allows us to override one of these. So this is actually called so there's set dither, and we should really call it set dither from remapper. To indicate where we're getting the data from. But there should also be one that's just void VGA, what did I call it? Set dither hint. And it would basically be, it would take in a color and a dither, enum, and the two destination indexes. Now, how? Actually, no, that's not too bad. That's not too bad. We can PT color RGB source enum PT dither type. So we just do all that with pointers, and it doesn't matter because we're going to be converting these to indices anyway. Okay, so we'll go uint 8t idx equals EGA map color so we'll just go A index, B index, and source index. And then it would just be a case of VGA dither source index type equals type. Gotta be consistent. Okay, and that's our generic API for overriding a dither hint. Yeah, okay. I'm happy with that. So that goes there. Set dither hint would then also be added to the driver. And we'd have to go into system and add that in. Dither hint. All this stuff. So that means we can go back to here, add another Okay, so then it would be... Hey, Smalls the Kobold. How's it going? Yeah, we're in the middle of like adding EGA support to this adventure game engine that we've got. As you can see here, look, isn't it beautiful? Like we've taken like all of these 256 colors and made it made it a little bit kind of more terrifying. But we've just added in like all of the glue that we need to be able to turn it off and on at will, or just be able to remap the palette at will. And eventually, like the aim is that we're going to be able to have like all the CGA palettes as well. Because
prompt service is required.
Oh, thank you very much for the follow, Smalls the Kobold. Yeah, so yeah, sorry for folks new to the stream. Basically, the little project that we're working on is like a adventure game engine for DOS. It's currently reusing like a lot of ideas that have been kind of nicked wholesale from the Scum engine and the Grime engine, which is used for a bunch of Lucasfilm games like Indiana Jones and the Fate of Atlantis used Scum, and Full Throttle used Scum, and later on like Grim Fandango used Grime. But yeah, it's essentially kind of like doing it's taking a lot of ideas from those existing engines and giving it a more modern touch. Like for instance, instead of like rolling our own scripting language, we're just using Lua and putting together stuff like that. So yeah, the majority of the actual kind of like logic, like the adventure game logic, is all going to be written in Lua, ideally. But there's just like a relatively small layer of like system-specific stuff which is being written in C, which is kind of what we're doing here. And yeah, so like one part of the code which is all C is like the driver code. So we have like a bunch of kind of raw because we're targeting DOS, like we have like a bunch of code here which targets like the VGA registers, so that we can, we set up like mode 13 and then turn on like double buffering and memory chaining, etc, etc. So we already have kind of like fairly low level control, but like the main addition that we've added now is the ability to basically say, okay, now pretend that, you've got all of these colors, but pretend that you only have like these 16 colors, and redither it using, the nearest match that you can, which is what this function does. And yeah, as you can see, it's great. Looks brilliant. So yeah, the next step that we're kind of doing from here, like the issue, obviously, which you can kind of see from here, is that you don't really want dithering on all the time. Like there are some cases, like you can see like the text down there, like that doesn't look very good dithered. It just is really noisy and unpleasant. So the way that we've kind of set up dithering, we have the option to kind of so we have the option to like manually override it for specific colors. So the idea would be we'd just have like at a base level do like auto conversion for something like this, but we'd have the ability to basically say, oh, but this color here, this color is special, do not dither this color. So that is the API that I've just added into the Lua engine here. So just doing a little bit of plumbing to get that all wired up. So, and yeah, the bit that I kind of hit is that we need to convert this back into a color object that we can hear. Oh, Smalls the Kobold says, people who can dither by actually drawing without filters are crazy. I've tried it in some pixel art attempts in the past and gave it up. Yeah, I agree. It is very difficult to kind of do by hand. Like, so some of the so like here's like some of the test art that I've been kind of putting together for the demo that's eventually going to come with this game engine. And as you can see, like I don't know, I've tried my best doing some kind of hand dithering here. Like, so like the crest terrarium here, like that's all hand dithered. There's some kind of like more plane dithers for the walls, which are kind of meant to be more subtle. Like, literally just kind of to do, like, give, like, a low color, you know, so, like, there's kind of, like, boring fills for the walls, and for, like, the side tables, this is all kind of, like, an attempt at hand dithering, but I don't know, I'm just kind of learning as I go, really. It's all very experimental and may or may not work. But I don't know, automatic dithering looks pretty good. Maybe we should just leave it as is. No. We better go ahead and do some more stuff. All right, so argument 1 is going to be a table, which means I need to look up the Lua API. Smalls of Cobalt says, which 16 colors does it use? Will you be able to feed it a palette? So right now, for testing purposes, I've just fed it the 16 color EGA palette. The way that we've kind of set up the algorithm, like, there's nothing stopping it from stopping us from being able to make, like, another API which allows you to, like, specify which colors are going to be your limiting colors. So I don't know, like, conceivably you might want to do that in some scenarios, but in terms of just, like, the out of the box kind of, like, fun feature, like, really what the aim for this, right, is that, I mean, while we're testing it here in VGA mode, eventually I want to write an EGA and a CGA driver for this, and to do that, you basically, obviously need to reduce it down to one of these beautiful palettes here. So, you've got, your poison green, groupie lipstick red, you've got jaundice yellow, searing blue, magenta, etc. And yeah, Smalls of Cobalt, like, raises the point, if it was an engine for someone to make games in, I would want to choose a palette. Yes, so the way that I've currently set it up, so leaving aside this kind of EGA remapping kind of stuff, so if I just switch it back to VGA mode, essentially the way it works is that this engine will just allow you to load in any indexed PNG file. And whenever you load in an indexed PNG file, it'll add those colors to the palette. And it will just keep doing that until it runs out of palette space. So there is kind of like an honor system component there. So, like, you will need to obviously, like, keep track of your color usage for the sprites that you're kind of putting into the game. But from a like, management in the game perspective, you don't have to worry about, like, are the colors in the right spots. Like, the engine will, like, the engine will try and remap all of the graphics in your game to match those colors. So it is entirely possible, like, one option might be, if you just want to do, like, nearest neighbor matching for, like, a 256 color palette, you can just, like, create an image with all 256 colors and make that the very first image you load. It doesn't have to be shown on the screen, but it's just the first image you load, and then that will, like, preset the palette for you. But obviously, yeah, like, we could make it so that you could just manually. I'll eventually kind of, like, add in some Lua commands that allow you to just manually, like, mess with the palette. But yeah, ideally, I just want it to kind of be as easy as, create indexed PNG files with whatever bitmap editor that you like, and most of the time it'll just work. So yeah, and yeah, this feature really only intended to kind of just provide a means for, like, auto down converting the graphics to either EGA or CGA. Okay, so I need to look at the Lua docs again. Lua get fields. Oh no, we want Lua get I. So pass on to the stack Lua ti, where t is the value at given index. Yeah, okay. So that's the address of our table, and then index is. Oh no, this is the index of the table on the stack, and this is the offset. Yeah, okay, we can do that. We can absolutely do that. So we'll go PT color. Oh, and I just realized that I've named these like color without the U, whereas everywhere else it's got color with the U. So I'll go back and mass rename that at some point. For now, PT color RGB equals Lua get I. Yeah. Stack index 1. I'll say that is so, oh, and we want that to be G and B. And then I mean technically we do it this way too. Oh wait. No, that pushes onto the stack. No. I want to fetch it. I want to. No, I did that wrong. Let's check stack. Lua check integer, check string, check option. So, oh my god, how do we do this? Got open libs, opt number, opt string, push fail, push result size. I just want to get wait, what was that thing it said? Always raise an error if the check is not satisfied. Okay. We don't need check. Pops. Because basically, it's okay if we concat copy get table next. Pop just removes it. Converts the Lua value at the given index to the signed integral type Lua integer. We're so close. We're so close, and we're just getting to the. We're just stuck on the friggin' lure. Oh no, well, no, sorry. I'm blaming the lure. It's actually the C. It's the C which is the problem. Which is we need to convert a list of 3 things in lure into integers in here. Oh, is it 2? There's pop integer, check integer. Okay, I think I understand. So for this, we would need to we'd basically just go lure get I and that would push like color, you know, the red value onto the stack, and then we'd go lure. How do we whatever. I think we need to do this for every single one, which is a bit manky, but you know what? I'm okay with it. I'm okay with it being... What? Oh my god. What? Why is my keyboard... Oh, come on. Okay. Okay, keyboard's working as it should now. Okay, so that's one color, and then we need to do it 2 more times. Okay. Good start. Then we copy this a second time. Right. There we go. So that should be our glue. Oh, I've got it around the wrong way. Got it around the wrong way. So 3, 3, 3, 4, 5, 6. Yeah, all right. Rebuild that, and then okay, so start off by ruining the colors. Set palette remapper. Then it should, with our new API, we should be able to go pt set dither hint, pt set, what did I call it? I did call it pt set dither hint. That time it has a function. I don't know why. I don't know why. But more importantly, if we start... Actually, firstly, let's get the palette. Let's get the palette. Because then with this, I can load this into Python and we can like start looking at some of the colors. From palette bytes AX. So here's our current palette, featuring all of these lovely colors. So this is like here, like for instance, here is the ramp that's kind of used for like the background image. Here's the selection of blues that are kind of used for like the sprite's clothing and stuff like that. So why don't we start off with here? Like we know that these blue shades here are used by this sprite. So why don't we kind of we'll use that as our test. pt set dither hint, and we'll say that the OX27, OX2D. Actually, we'll go the darkest one first, because like I think this is the outline. This is the outline color, so we can turn off dithering on that. We'll see how that looks. 1X, 19, 1X87. Hang on, what did I end up? 0, 1, 2. Okay, so it's number 2. 2, and then the two colors that we would want is just 0, 0, 0, 0, 0, 0, AA, 0, 0 A. Okay. Little bit arduous, but we'll keep going. How about like the lightest shade? If we go like and set the lightest shade, which is 4-3 4B BA to, and then we change that to like it's hard to see if it doesn't look like it's really doing it. Doesn't really look like it's doing anything, which concerns me. But it is calling. It is calling set to the hint. Oh. Oh, okay, I think I know what's going on. I think I know what's going on. The issue is that this function here, set to the hint, VGA revision, we need to do this in order to like update the graphics. Is it? Okay. So quit. Let's try that again. So turn on the EGA mapper. Adding one of these. Yeah, look at that. Look, it's fixing the colors. Yeah. Oh my god, this is so good. All right. This is real satisfying. Okay, maybe we can fix the flesh tone as well. There's quite a few flesh tones. FF 5555. I'll just copy that for like everything except like that's it. Make it blood red. A1 7258 and then that should be oh, I only use that on the neckline? Okay, fine. C2 A5 69. Wait, 8569. There we go, got the eyes. And I guess D4, 9, 3, 2. Yep, got the mouth. That means we can go ahead and I should really print these in an order which is easier to do stuff with. Oh, right. I forgot how my own library works. Okay, good. And now I can do more aggressive copy pasta. Then use the lighter shade. What? Oh. No. No, not that color. This one. Maybe I should actually read before I'm typing. Maybe that's how we do it. It's probably this one, I guess, because that's got red as the highest. Yeah, okay. I mean, copy paste this. Yeah, but it's looking better. Like I can definitely see. Yeah, I could definitely like see myself just going through the motions of like making a strict EGA color palette with this. Yeah. Okay. I mean, I think I might wrap it up there for tonight. It's kind of getting a bit late, but yeah, maybe next time we'll have maybe next time I'll have gone through and like remapped all the colors so that they actually kind of look nice in EGA as opposed to kind of looking a bit manky, which is where they are now. But anyway, let's see who is online and who is doing things. Okay, Absnerdity is it's doing something retro-y. So yeah, okay. I think we'll just raid Absnerdity. It's been a while since we raided them. But yeah, thank you once again for tuning in to, I don't know, it really feels like I'm just talking to myself a whole bunch of the time. Like just yammering to try and figure out the series of steps that we need to do to actually kind of make progress in this crazy thing. But I appreciate it. I appreciate your company and have a wonderful rest of your evening. Bye.